Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. In the last lecture we were learning how to compute the weighted mean for the data set where each data item carry different weights or different importances. We put one example, compute the weighted mean for the 5 purchases of different 5 raw materials, and we developed the data table to compute the weighted mean for the 5 different raw materials as this is given in front of you on this slide. Weighted mean for 5 purchases. The first column represent the number of purchases. The first one define first raw material, 2 define second raw material, 3 define third raw material, 4 define fourth, and 5 define fifth raw material that purchasing agent is going to purchase for a company. The second column represent the 5 different prices per kg or cost per kg of the different 5 raw materials. Cost per kg or price per kg, we are using the symbol XI that will represent cost per kg or price per kg of the 5 different raw materials, where I is the subscripted number which runs from 1 to 5 because we have 5 different raw materials. If I is 1, so X1 will represent that $3 is the per kg price or cost of the first raw material. If this I is 2, so X2 will represent that $2 is the per kg price of the second raw material. If this I is 3, so X3 will represent that 4 is the per kg price of the third raw material. If this I is 4, X4 will define that 1 is the per kg price or per kg cost of the fourth raw material, and 5 represent the per kg price of the fifth raw material. Third column represent number of kgs, or we are using the symbol Wi, which represent weight of each raw material. W stands for weight or for the number of kgs that the company required to purchase of different 5 raw materials. If this I is 1, so W1 will represent that the company need 100 kgs of the first raw material. If this small I is 2, W2 will represent that company required 150 kgs of second raw material. If this I is 3, W3 will define that company required 50 kgs of third raw material. If this I is 4, W4 will define that company required 200 kgs of the fourth raw material, and this 30 represent that company need 30 kgs of fifth raw material. These are the 5 different kgs of the different raw materials. We call these kgs are weights of every raw material, different weights. In the fourth column, we weight each raw material, each data item according to its corresponding weight. Statistician will multiply each raw material, means each data item, with its corresponding weight to calculate the total weight of that particular data item. And here we have the data items raw materials, so the weight of the particular raw material. Fourth column we represent by Wi multiplied by Xi, where Wi represent weight of the data item, X represent the per kg price or cost of the raw material or of the data item. So we will compute the weight of each raw material one by one individually. So the fourth column represent the 5 different total weights of all 5 raw materials. So the first raw material price per kg, cost per kg is $3. The weight of the first raw material, that is 100 kgs. So to weight the first raw material, first data item, we will multiply 3 with 100 as this is given in the fourth column. 3 this is sign of multiplication, multiplied by 100. 3 multiplied by 100 is equal to 300, and this is the total weight of the first raw material, or you can say the total cost purchasing first raw material 100 kgs that the company has to pay. Now the weight of the second raw material, so data item is the price per kg of second raw material, you can say $2. The weight of the second raw material is 150 kgs. To compute the total weight, the total cost, statistician will multiply the price per kg with the total number of kgs, so this is equal to $300. This is the total cost that company will pay to purchase 150 kgs of second raw material. Now the weight of the third data item or third raw material, so total weight, the weight is 50 kgs. Per kg cost or price is $4, so we will multiply 4 multiplied by 50 is equal to $200. This is the total cost that the company has to pay and purchase 50 kgs of third raw material. Now the weight of 4 data item, price per kg $1, total number of kg is 200 grams, so 1 multiplied by 200 is equal to 200. The company has to pay $200. That is the total cost of the company to purchase 200 grams of the fourth raw material, and the company is purchasing 30 grams of the fifth raw material. Price per kg is 5, so to compute the total cost, per kg price multiplied by the number of kgs is equal to 150 kgs. So these are all 5 different costs of 5 different raw materials. Now we will add all the 5 different raw materials individual weights together. We will add them together and we compute summation Wi is equal to 530 kgs. These are the 5 different raw material number of kgs that company required, and when we add them together, these are the total number of kgs, 530 kgs the company need, and to purchase these 530 kgs the company pay the total cost $1150. So these are the costs of the different 5 raw materials. We call this is total weight. We will add them together, 300 plus 300 plus 200 plus 200 plus 150. So summation Wixi, this means I'm going to add together all these values and this give the total value $1150. Now we will put the number of kgs 530 and we will put the total cost of the 5 different types of raw material $1150. We will put this in the weighted mean formula and we will compute the mean, the average cost, weighted average cost per kg of the 5 different raw materials. As this is mentioned in the note, the 4th column represent the weight of each raw material according to its corresponding weight. We will add all these individual weight, we will add them together, and now the total weight is total cost, which is $1150 to purchase the 530 kgs. We will put these all values in this weighted mean formulation. X bar is a symbol for the sample weighted mean. Formula summation Wixi divided by summation Wi. This summation Wixi represent the total cost that company pay to purchase the 530 grams, and summation Wi represent the total number of kilograms. So we define the total cost value by the number of kilograms, so we compute 2.1698 per kg price. So it's mean when businessman, or you can say purchasing agent, is going to purchase the 5 different raw materials, so the average weighted cost of the per kg of every raw material statistician calculate, that is $2.1698. Interpretation: $2.1698 is the weighted average cost of each raw material per unit mean per kg, because measurement unit in here we put kgs, kilograms. So we can say interpretation means that purchasing agent will pay per kg for every raw material $2.169. to purchase the raw material. So this is the way as we elaborate in this data table. We have the 5 raw materials, prices per kg, number of kgs, and the total cost that the company pay. So in this way, as we discuss in this table, we develop a table for the 5 purchases. In this way, statistician will compute weighted mean, because this is not a simple mean. In this type of example, every data item carry different weight, different importance. So we cannot use a simple mean. Statistician has to use weighted mean, and we use the formulation of weighted mean and compute the weighted average cost per kg. Now in the next section, we are going to differentiate simple mean and weighted mean. So in simple mean, every data item of the data set carry equal weight or equal importance. In a simple mean, every data item carry equal importance, equal weight. There is no need to calculate the weight of all the data items, and statistician will add them together, or add together all the data items and divide it by the number of data items and compute the simple mean. But in the weighted mean, as we discuss in this data table for the 5 different purchases, weighted mean, every data item carry different weight, different importance, and statistician weight each data item according to its corresponding weight to compute the accurate weighted mean and avoid the misinterpretation of the data set. So this means, and in this type of example where each data item carry different weight, statistician cannot use the simple mean, because in the simple mean we will just add together all the available data items and divide it by the number of data items. Like for example, in this case, if we are using the simple mean, so the average will be overestimated. We will just add together the 5 different prices per kgs of all the 5 raw materials and divided by 5. So 3 plus 2, 5 plus 4, 9 plus 1, 10 plus 5, 15. These are the different 5 prices of the different 5 raw materials, but per kg. But we add them together, and 15, the total data items are 5, 15 divided by 5, the average value is $3. So the average cost, simple mean, we compute $3, that is overestimated. This $3 will give us wrong average value, and it will overestimate the per kg price as well as the total cost of the company. So in this case, statistician cannot use the simple mean. This mean will misinterpret the data set. Statistician has to weight each data item according to its corresponding weight, because company is not purchasing 1 kg, that we are calculating the average cost only for the 5 kgs, each raw material 1 kg. So every data item kgs are given. 100 kgs the first raw material, 150 second, 50 third, 200 fourth, and so on and so on. So in the weighted mean, statistician has to first weight each data item and then compute the mean value. That is why there is a little difference between the two formulations. This is the weighted mean formula, where we are weighting each data item and divided by the total weight. But in the same simple mean, let me take you back to the simple mean that we put a different example and we calculate. Like for example, this is the simple mean. We are calculating the average number of coronavirus infected patients. So by adding together all the data items and divided by the sample size. So we have only 4 data items. We add them together and divided by the size 4. So we compute the mean value. So this is just for the data set where each data item carry equal importance or equal weight. But when the data set includes such data items where each data item carry different weights, then statistician has to first weight each data item and then compute the mean value to compute the accurate weighted mean and to interpret the data set in exact and accurate way. So this is all about the difference between the simple mean and weighted mean. Now we are switching toward the next terminology, weighted mean for group data. we are going to learn how to compute the weighted mean for group data. If the data is not given individually and the data is given in group form, in classes form, so then how statistician can compute the weighted mean? So weighted mean for group data. In this section we will learn how to compute the weighted mean for group data when data is given in classes form and data is not given individually. So we are first let me introduce the procedure, the methodology, that how a statistician can compute the weighted mean for the group data. Where data items are not available, statistician has to develop data items, determine data items using the given classes and given frequency distributions. So procedure: statistician will use midpoint formula to determine data item for each class by adding together lower limit of the class and upper limit of the class and divided by the 2. It means methodology is this, that if the data is given in classes form, so frequencies are given, classes are given, data items are not given. So in the very first step, statistician has to develop, determine, define data items. How he can define? Using this midpoint formula. Xi is equal to lower limit of the class plus upper limit of the class and whole divided by this 2. Now what is Xi? Where Xi represent individual data item of the individual particular class. This I subscripted number runs from 1 to n numbers of data items. If the value of this small I is 1, so x1 will define the data item, first data item of the first class. But if this I is 2, then x2 will define the second data item of the second particular class. If this I is 3, so x3 will represent the third data item of the third class that statistician will develop by using the midpoint formula. So I am putting one example that how we can compute the weighted mean for the group data using midpoint formula. For example, compute the weighted mean for the group data is given in frequency distribution table. Mean in example, we have the data table, which is frequency distribution table. Frequencies are given in the second column, and in the first column we have only 5 different classes. So data items are not given. In the very first step, statistician has to develop 5 different data items for the 5 different classes using midpoint formula. We are switching toward this calculation to develop the data items and to weight each data item and to compute the weighted mean. So midpoint formula, Xi is equal to lower limit of the class plus upper limit of the class whole divided by 2, where Xi represent individual data item of individual class. This is the frequency distribution table that we will complete. Now let me tell you that how statistician can develop data items and how statistician will weight each data item. We are starting by determining, defining, developing the first data item for the first class. So this is the first class. Lower limit of the first class is a 12, upper limit of the first class 15. Formula is this: frequency of the first class is 9. Midpoint formula to develop the data item is given. L stands for lower limit of the class plus U stands for upper limit of the class whole divided by 2. Now lower limit of the class is 12 plus upper limit of the class is 15, and we are whole dividing by 2. So this implies 12 plus 15, 27 whole divided by 2 and is equal to 13.15. So in this way statistician will develop data item for each class. You can see that this 13.5 is within the range of lower limit 12 and upper limit of 15 of the class. Now we are going to develop data item for the second class. Lower limit of the class 16, upper limit of the class 19, 16, lower limit plus 19 upper limit and divided by the 2. Why we are dividing by 2? Because we are calculating the average value of 2 data items. That is why the total number of data items in the class are 2. That is why we are dividing by 2. This implies 16 plus 19, 35 whole divided by 2, and this is equal to 17.5. So 17.5 is the data item of the second class. Now data item for the third class, lower limit of the class is a 20 plus upper limit of the class is 23 whole divided by 2. This implies 43 whole divided by 2 is equal to 21.5. So data item for the third class is 21.5. Again, lower limit of the fourth class 24, upper limit of the fourth class is 27. Add both values, 24 plus 27 whole divided by 2. This implies 51 whole divided by 2 and is equal to 25.5. In this way, students, you can compute the data item for the fifth class as well. Just simply add lower limit of the class and upper limit of the class and divided by 2. Now we are switching toward the fourth column. In fourth column, we are multiplying the data item xi, each data item of the each class, with the corresponding frequency to weight each class or each data item. So fi multiplied by xi, frequency of the first class is 9, as this is very clear from this column 2. These are all the 5 different frequencies of the 5 different classes. So first class frequency is 9, data item of the first class is a 13.5. 9 multiplied by 13.5 is equal to 121.5. This is the total weight of the first data item 13.5 by multiplying with its corresponding weight, which is frequency 9. Now the weight of the second class, 4 is the frequency of the second class, multiplied by data item is 17.5. So 4 multiplied by 17.5 is equal to 70. One thing must be clear to you, that these are the data items and these are the frequencies, where frequencies represent weight of each class. Weight of each class. So weight of the third class, frequency weight is a 3, data item 21.5. 3 multiplied by 21.5 is equal to 64.5. Now weight of the fourth class, frequency 2 and data item 25.5. 2 multiplied by 25.5 is equal to 51, and in this way, students, you can compute the weight of the fifth class by multiplying the frequency 2 of the class with the data item 29.5, and the total weight of the fifth class is 59. Now again, simply we will weight all the individual weights of the 5 classes. Summation fi is equal to 20 observation, 20 data items of the data set, and in here we will add all the weights of all the 5 classes. So that is summation fi xi is equal to 366. We will put these two statistics, these two measures in the weighted mean formula, as this is clear from the note. Put all the values in the weighted mean formula from the table. Summation fi xi is equal to 366. Summation fi is equal to 20. Now we are putting in a weighted mean formula, where we are dividing the total weight by the total observation. Summation fi xi divided by summation fi, 366 divided by 20, and x bar mean value, weighted mean value, is equal to 18.3 days. Now interpretation is this, that every client audit will consume approximately 18.3 days. So this is the mean value for the group data. Interpretation means that every client, every university audit will consume approximately 18 days in completing to complete their audit. So this is the interpretation. Again, in the group data we cannot use simple means, because every data item carry different weight. So simple mean will give the wrong mean value and it will misinterpret the data set. So statistician has to compute weighted mean. First weight each data item according to the corresponding weight, and then statistician has to compute the weighted mean using weighted mean formulation. everything is clear in this data table as we read and understand and analyze this data table stepwise from the first column to the last column and to the end of the formulation. So I'm again repeating interpretation. Every university audit will take approximately 18 days.